Hi girls, today we are going to see the revision for the 5 chapters. For core 10 you are having 5 chapters and we are going to revise those 5 chapters and we shall see one by one. The first one is quantization of charges, and quantization of charges you mark this one, that is quantization is nothing but the integral multiple of the fundamental unit of charge, and you have to study about the value of E, and you read this example 1. Next, in this Coulomb's law. So Coulomb's law, this paragraph gives the Coulomb's law, and you have to write about the force, and K is equal to 1 by 4 pi epsilon naught and the value of epsilon naught, and here this is Coulomb's law in vector form. And in this we are going to see the 3 differences between gravitational force and Coulomb force. So the 3 differences are here that you have to study. And next, superposition principle. In this you have to study about this principle with this equation, and this is the another question. This is the answer for the 4th question in your book back, and here this is the superposition for all the charges, that is if it have a number of charges, this is the superposition principle that you have to study. Next, you have to read a field and electric field lines. In that you are having the electric field definition here. The electric field definition with this equation you have to study, and there are some properties of electric field. You can study any 5 or any 5 points in this part. And next, electric field lines. This is the definition for electric field lines, and so these 3 electric field vectors are visualized by the concept of electric field lines, and you have to write about electric field lines in this. And next you are to study about the dipole definition here, and the examples for dipole, and here the SI unit of dipole moment is Coulomb meter, that you have to study, and this is electric dipole moment, and the equation for electric dipole moment is P vector is equal to 2QA, and here this is dipole moment for a number of charges. This you have to study, and you have to read all the example problems. And here this is electric field due to a dipole, and here there are 2 parts, axial line and equatorial line. These 2 are 5 mark questions, and in the axial line there is a big derivation, and you know this point is along the axial line, and here this is equatorial plane. For this, the point C is on the equatorial plane, and you have to derive these equations. And next, torque experienced by dipole in the uniform electric field. And next you have to study about the electric potential definition, and next electric potential due to a point charge, and that you write the derivation and equations, and this is the final derivation. V is equal to 1 by 4 pi epsilon naught into Q by R. And next we are going to see about equipotential. This is electric potential at a point due to an electric dipole. This is also a very important 5 mark question. In that, at point P you have to find out what is potential, and there are minus Q and plus Q. You have to find out V1, V2, and you have to add that, find out 1 by R1, 1 by R2, and final potential you have to find out. Next, equipotential surface. You have to read the definition for equipotential surface. And next, properties of equipotential surfaces. There are 2 points in that, and relation between electric field and the potential. For that you read this equation 143 and the definition for potential. And next, Gauss law. You know, this is the definition for electric flux, and you have to read the unit for the electric flux. And next, you see this problem, example 117, and next Gauss law, and this is Gauss law. If a charge Q is enclosed by an arbitrary closed surface, then the total electric flux phi E through the closed surface, and you have to write this equation. And application of Gauss law, in that there are 4 applications, and you can study the first one. The first one is due to infinitely long charged wire, and this is the first application, and this first application is frequently asked. And next, infinite plane sheet, and the third one is due to parallel charge sheets and uniformly charged spherical shell. And you can for time being you can read the first application. Next, electrostatics, and here in this you have to study about electrostatic shielding and electrostatic induction. And here we have to explain about electrostatic induction. Next, dielectric, the dielectric non-polar molecules and polar molecules. Then you read the definition for polarization, these 3 lines you have to read. And dielectric strength, this is also a very important 2 mark question, dielectric strength. Next, you have to study about capacitance, define capacitance and its unit. The SI unit of capacitance is farad, and you can see this example 120. And next, capacitors in series and parallel, this is a 3 mark question, either individually or combined it can be asked. Next, you have to study about action of points or corona discharge, and you have to read the full one. And the finally Van de Graaff generator 5 mark question with this example 124. Joule's law, and you can study this problem, and you give the definition for Seebeck effect, Peltier effect and Thomson effect, and you can explain the Thomson effect. Here the applications of Seebeck effect, there are 3 applications that you have to study. And next comes the 3rd chapter, and in the 3rd chapter magnetism and the effects of current in that. And here dip and declination, here declination and inclination and the horizontal component. Here you can read this problem. And here there are some properties of magnets, there are 5 properties, you can prepare any 3. And next, magnetic flux, definition for magnetic flux and magnetic flux density, that is a 2 mark question. And Coulomb's inverse square law in magnetism, this you have to study for 2 mark, and this problem you prepare well. And as usual, axial line and equatorial line, as in electricity chapter, here for magnetism also you are having axial line and equatorial line, and you can read those for 5 mark questions. And magnetic properties, you can read magnetizing field, magnetic permeability, the definitions, and here the intensity of magnetization, here the intensity, and these formula you should study. And give the definition for magnetic induction, magnetic susceptibility, and you read this example, and the diamagnetic, ferromagnetic, and there is a comparison, and you write you study all the 4 properties, and you can compare dia, para and ferro, that is also a 5 mark question. And Curie-Weiss law, that you have to study. Next, hysteresis laws, in that what is hysteresis, that you should study. And this is a comparison between soft ferromagnetic materials and hard ferromagnetic materials, that you can prepare. And in magnetic effects of current, here right hand thumb rule, to study this right hand thumb rule and Maxwell's right hand rule. And next you can study Biot-Savart law, this is also a very important 3 mark question. Here this is do you know, you can read this part. And next, this is a very important 5 mark question, magnetic field due to a long straight conductor carrying current, and can axis of the current carrying coil, either you can study this or study this one. And tangent law, to study what is tangent law. And this is right hand thumb rule. and right hand thumb rule. Ampere circuital law, this Ampere circuital law you have to study, and study this example 315. And this is a 5-mark question, magnetic field due to a long current carrying solenoid. This is a 5-mark question. And a toroid, what is a toroid, that you have to study. And a Lorentz force, you have to study these 5 points. These 5 points, there are 7 points, and you will be ready with all the 7 points, because this is also a frequently asked question, magnetic Lorentz force. And you can study this example 317, and you study this example 319 also. And here motion of the charged particle under crossed electric and magnetic field, this is also a 5-mark question. And cyclotron, either you can study that derivation or cyclotron derivation. Then force on a current carrying conductor placed in a magnetic field, this is also a very important 5-mark question. And Fleming's left hand rule, this Fleming's left hand rule, you study this, and this is a very important 5-mark question. And torque moving coil galvanometer, if time permits you can study this one, and you can study this problem 326, and conversion of galvanometer into ammeter and voltmeter. So these are the things you have to study in the 3rd chapter. Next we are going to study about electromagnetic induction and alternating current, the 4th chapter. And this is a very big chapter, and you have to study about magnetic flux and its equation, and this example 4.1. And next, Faraday's laws of electromagnetic induction. There are 2 laws in that, and this is combined Faraday's law, but you have to study this one, the first law and the second law. And the first law is, whenever magnetic flux linked with a closed circuit changes, an EMF is induced in the circuit, which lasts the circuit as long as the magnetic flux is changing. And here the magnitude of induced EMF in a closed circuit is equal to the time rate of change of magnetic flux linked with the circuit. That is, when magnetic flux changes, an EMF is induced, and here the magnitude that induced EMF is equal to the time rate of change of magnetic flux. These 2 laws you have to study, and study this example 4.3. And next, Lenz law, this is a important 2-mark question, Lenz law. And Fleming's right hand rule. So already in the 3rd chapter we have studied Fleming's left hand rule, and this is Fleming's right hand rule. This is a different, and here you have to write according to this order. First index finger, and thumb and middle finger. The order should not be changed, index finger, thumb and middle finger. And similarly for left hand rule, you have to follow the same order. If you change that, you will not get the marks. And you can study this example 4.8. And the eddy currents, what are eddy currents, you have to mark this and study. And next, self induction. In the self induction we are having this definition, define self inductance, and this is the unit of inductance. Unit of inductance is Henry, and this is self inductance, and this is self inductance of a long solenoid. This is also a frequently asked question. This is a 5-mark question, self inductance of a long solenoid. You have to study up to this, and you can read this example 4.11. This 4.11 is also frequently asked, and this is a definition for mutual inductance, and you have to study what is a unit of mutual inductance. Both for mutual inductance and self inductance you are having the same unit, Henry. And next, methods of producing induced EMF. In that you have to study by changing the area, and here by changing the orientation. So these 2 topics you have to study, by changing the area and orientation. And AC generator is a very big question. When you see the construction, it is a very big question. If time permits, you study that. And next, transformer. And here transformer is a very easy to read. Here you have to write about the principle. The principle is mutual induction, and you have to write about the construction. And here you are having a primary coil. This is a secondary coil, and here in this left side you are having primary windings, in the right side you are having the secondary windings, primary voltage, primary current, primary turns, and here secondary voltage, secondary current, secondary turns, and you have to write about the working. So when AC is passed through this, the magnetic flux changes. Because of the change in magnetic flux, an EMF is induced here, and when you see here the number of turns is less, here the number of turns are more. So this is a step up transformer, and you have to write these equations. You have to find out EP and VP, then again ES and VS. So the primary, secondary ES, VS you have to write, and this is the constant known as transformation constant, and here input power is equal to output power. Using that you will get a ratio like this, and these are the two cases, and you have to write out the efficiency of the transformer, which is usually given by output power by input power into 100%. And so these are the things, and you have to draw this diagram and study the equations carefully, and energy losses in a transformer. And this is advantages in long distance power transmission, that you can read some points. You select 5 or 4 points, and you can study this example 416. And next, in alternating current, what is an alternating current, that you have to study, and you write the definition of RMS value of AC, that you have to study, and you can study this problem. And there are 4 topics. First, AC circuit containing pure resistor, then inductor, then capacitor, and the fourth one is RLC circuit. The fourth one is RLC circuit. So having 4 topics: AC circuit with resistor, inductor, capacitor, and RLC circuit, and you can read any 2 topics in that. And this is a definition for quality factor, it is also a frequently asked one. So write these 4 lines for quality factor. And power in AC circuit, you have to define what is power. So this is a definition for power, and study this advantages and disadvantages of AC over DC. So read these points. This may be asked in 3 mark question. So this is analogy between electrical and mechanical quantities. You read once this one. So this is about the 4th chapter. Next we are going to see about the 5th chapter. This is a very short chapter, electromagnetic waves. So first you have to define what is an electromagnetic wave. For that you are having this displacement current, Maxwell's correction. These equations you should study, and Maxwell's equation integral form, you are having main 4 equations that you have to prepare well. And what are electromagnetic waves? This is the definition for electromagnetic waves. They are non-mechanical wave which move with the speed equal to the speed of light, and this definition you have to study. And then properties of electromagnetic waves, there are 8 points in that. You can prepare any 6 points. So the electromagnetic waves are produced by accelerated charges, and next they are non-mechanical wave, and they do not need any medium for propagation, and they are transverse in nature, and the electric and magnetic field vectors are perpendicular to each other and also to the direction of propagation. And here it is the waves travel with the velocity of light, that you have to write, and C is equal to 1 by square root of epsilon naught mu, whose value is equal to 3 into 10 power 8 ms power minus 1. And here you have to write about what is permittivity and permeability and the relation between them. So N is equal to here C by V, where N is refractive index, C is velocity of light, and V is velocity of light in medium. And here they are not deflected by electric and magnetic field because they are not having any charge, and they also exhibit interference, diffraction, polarization. And electromagnetic waves carry energy, linear momentum, and angular momentum. So there are 8 points in this. You can study any 6 points. Then sources of electromagnetic waves. In that you are having an electromagnetic spectrum starting from radio up to gamma. You are having 7 types of waves. You have to read how they are produced and what are the uses. Mainly you have to study the production and uses. So radio waves are produced by accelerated motion of charges in the conducting wires. And what is the use? So the first paragraph will give how it is produced, and the second paragraph give the information about the uses. So I have to study all the waves and their uses. That may be asked in 2 mark question. And next, there are types of spectrum: emission and absorption spectrum and Fraunhofer lines. And here the emission spectra and absorption spectra. Emission spectra is individually a 5 mark question, and absorption spectra is another 5 mark question. Here emission spectra means just a light is allowed to pass through a prism and it is examined. And there are 3 types in this: continuous emission spectrum, line emission spectrum and band emission spectrum. You have to study how they are produced and the examples. That is, here the spectrum obtained from carbon arc and incandescent solids. And here also which spectra of atomic hydrogen, helium. And when you see band emission spectrum, spectra of ammonia gas in the discharge tube. So these are the examples. So you have to study how they are produced and the examples for these 3 spectrums. Similarly, for absorption spectrum, continuous, line and band. In that also you have to study with examples. And Fraunhofer lines is a 2 mark question. What are Fraunhofer lines and what is the use of Fraunhofer lines? And this is a very small chapter. And all the best girls, prepare well. And for 1 mark you will get also the interior part, in the interior part also. So prepare well. All the best girls.